Hi guys. So as you know, in chapter 2, we're talking all about matter, and we spent some time talking about the properties of matter, extensive, intensive, physical, and chemical. And what we're going to do now is we're going to talk about what is matter. So we can describe it, but what is it? And so in general, what we can say is that matter can be either a mixture or a pure substance. So generally speaking, if something is a mixture, it's made up of one or more things. Or it's not a mixture and instead it's just made up of one thing. So this would be a pure substance. So in short, a pure substance is made of one thing, where a mixture is made of more than one. In today's lesson, we're going to be looking at mixtures and pure substances and classifying what is a mixture, what is a pure substance, and what kinds of mixtures and pure substances can we see. So let's start with mixtures. A mixture, to define it, is a physical blend of two or more different types of matter, each which retains its own properties and identities. So let's break that down a little bit. First, we have this concept of a physical blend, which means this is not a chemical change. That means that the substances do not change in their composition or identity when they get mixed together. So it's a physical blend. They're just mixed. They don't change who they are. They're just remixed. So if you took sugar and salt and you were to mix them together in some sort of funny trick at a restaurant or something, or at your house, and so you mixed salt into the sugar, and then your mom or dad went and got that mixture and they put it in their coffee and they stirred it up and they tasted it, it wouldn't be something new. It wouldn't be a new flavor. It would be a mix of salt and sugar. The sugar would retain its own properties of tasting sweet, and the salt would retain its own properties of tasting like sour, spicy, kind of however you describe salty. They would keep their own properties. So in a mixture, we're looking at two or more things, but they each stay true to their own selves. They stay as their own composition and identity. So there are two ways that we can mix things up. The first one is called a homogeneous or homogeneous. Homogeneous is typically how you see it, but we say heterogeneous, and so homogeneous is another way that you can say it. Doesn't make any difference to me. You're mostly going to be spelling it and writing it anyway. But in a homogeneous solution, the components are all equally distributed. All you need to know to think homogeneous solution is think Kool-Aid, think Crystal Light, think Country Time lemonade. This is where you're taking one of those like kind of sugary packets and you put it into water and you stir it up. And the idea is that from the top of the container all the way to the bottom of the container, the composition is exactly uniform. So one of the things I used to tell my classes, if you take a sip from the top, or if you stuck a straw down to the bottom and you slurped from the bottom, you would get the exact same composition of mixture because it is homogeneous. It is the same throughout. The other type of solution that we have is a heterogeneous solution. So heterogeneous means that we are unequally distributed throughout. So sand in water or dirt in water, those would be examples of heterogeneous solutions. So this would be like little chunks or pieces of things. I had a student one time, she was in nursing school, and I was helping her with her chemistry, and I was looking over her test, and her teacher had said that there was a glass of lemonade, of homogeneous lemonade, and she needed to make the solution heterogeneous. How would she do it? And her answer I thought was pretty funny because she said, add some ice cubes and some lemon slices. That's exactly right. Then it is no longer the same throughout. If you were to pour the contents of that cup into 4 different cups, you might get 4 different amounts of ice cubes, lemon slices, and lemonade. She has made it heterogeneous. So it doesn't need to be fancy to make something heterogeneous. It just needs to be uneven. Examples from your life that you may recognize are something like granite. If you have granite countertops in your house, they'll have these like really pretty veins or differences in color or flecks or size of the little pieces inside of it. that is a heterogeneous mixture. Caesar salad dressing is a heterogeneous mixture. You have kind of like the islands of cheese in the creamy dressing. That's an example of a heterogeneous mixture. No matter the mixtures, it is usually possible to separate them. So you can separate them maybe by filtering. So if you were to mix, let's say, coffee grinds and water, and then we run it, so that would be a mixture, a heterogeneous mixture at the top, and then you would run it through the filter paper and you would end up with the coffee at the bottom. Then you filtered out the coffee grinds. Or maybe you have sand and water mixed together, and so you filter out the sand by running it through some sort of sieve or something. Another way to separate things is to distill it. This is a way to separate a smaller particle, something that would slip right through the filter, like let's say Kool-Aid. It would be pretty hard to get the Kool-Aid particles out, you couldn't separate them through a filter paper. So instead we distill it, and the way that you distill something is you heat it up, and as the gas rises, then you condense it back down again and you make a liquid. This is how you get distilled water, how they clean water is through a process of distillation. I am not going to ask you specifics about filtration or distillation on the test. What I do want you to know is that filtration and distillation are examples of ways that you could separate a mixture, and that mixtures, by definition, can be separated, that most mixtures can be separated because they are just physical blends of two or more kinds of matter. So we're kind of going around in a circle, right? Because they're physical blends of two or more types of matter, we should be able to separate them. The ways to separate are filtering and distilling. Okay, so what about milk? Okay, so when we talk about different solutions, I'm going to be giving you things like air. Okay, air is a homogeneous mixture. Or like we already said, granite is a heterogeneous mixture. Chocolate chip cookies are a heterogeneous mixture. Pizza is a heterogeneous mixture. Lemonade is a homogeneous mixture. But what is milk? So the question about milk is a little bit interesting. What I have here is a glass of milk that is not homogenized. So milk in its raw state is heterogeneous. It has this cream that rises, this fatty cream that rises to the top, and then there's this milky layer underneath. So if you've ever heard milk called skim milk, okay, it's like a generalized term. What they used to do, so my family was dairy farmers, so I know this, okay? You'd milk the cow, you'd separate that milk, and the cream would rise. You've probably heard that. That's a saying, right? The cream always rises to the top. That means if you're like the best, even if you get knocked down, even if you get churned up into the milk, you will rise to the top, right? Because the cream always rises, because the cream was the best part of the milk. If you take like a ladle, this is like really old-fashioned stuff here. If you take a ladle and you pull the ladle across the top of the milk, so you would like scoop it right here, scoop that up. If you pull the ladle across the top of the milk, what you end up with is skimmed milk, right? Like a pool skimmer, when you like pull off the like dirt and stuff at the top of the pool. If you skim the milk, then what's left underneath was called skimmed milk, and we call that skim milk, right? It has less fat content. And the top would be called the cream, okay? And then you would take that cream and you put it in your coffee. It has a higher, richer content of fat to taste better. And so you put this, you would have the cream, right? So you have the cream of the crop, the best. You'd have the cream, and then you would sell the skim milk underneath. Well, now, I mean, technology has gotten better even in milk distribution. So now instead of having the cream and skim milk, we have 1% and 2%. That's depending on how much milk fat they leave. So if they leave 2% of the milk fat, then that's 2% milk. If they leave 1% of the milk fat, that's 1% milk. If they do non-fat, then they've removed this entire set of cream. The heavy cream, whipping cream, that's this top part. Point to all of this, besides milk knowledge, because who doesn't need to know this, besides milk knowledge, is that when you go to the store and you buy milk, it says on the carton, homogenized milk. And I just want you to think about what that means. that means that they have treated that milk in such a way that the cream no longer separates from the milk underneath, and it stays all put together. So whether they left 1% or 2% or all, that would be whole milk, of this fat there, they have now treated the milk so that it becomes homogenized, so that it's all the same throughout. So as we finish today, we're going to be practicing in the beginning of class tomorrow, identifying substances as either being homogeneous substances, or heterogeneous. And so I want you to walk around your house to spend today, as you're kind of existing in the world, thinking, is this a homogeneous substance or is this an example of a heterogeneous substance? We'll do some worksheets and some class time to really try to get this idea of the different types of mixtures. First of all, that most matter is a mixture, and then what type of mixture it is, to try to get that all kind of organized in our minds before we move on to our next lecture piece, which will be, well, what if it's not a mixture? What if it's just one type of thing? Well, then, of course, it's going to be a pure substance. I'll see you guys later.